Hello everyone, I'm Mohit Jain from MJ's Maths and Stats with sample questions 581 to 600, volume 6.4. Questions specially designed with help of previous year questions of TCS, NQT and Ninja. In 4 years, Gargi's father age is twice as Gargi. In 4 year means after 4 years. That means Gargi's father age would be f plus 4 after 4 years, would be twice Gargi's age after 4 years. Gargi's mother's age was twice as Gargi 2 years ago. That means m minus 2 should be equals to twice the age of Gargi 2 years ago. If Gargi is 32 years old in 8 years from now, that means Gargi's present age is 32 minus 8, that is 24. What is the age of Gargi's mother and father now? So, father age would be 2 times 24 plus 4, 28 into 2 is 56. Minus 4 will be 52. So father age would be 52 years. Now m minus 2 is twice 24 minus 2, 22 into 2, 44. So mother's age is 44 plus 2, that is 46. The kids Tina and Manna carry some fruits. Being tender and small, each could carry only a single digit number of fruits. Manna has 3 times the fruit that Tina has. That means Manna has got 3 times Tina. So we have the first equation set, m equals to 3t. If the digits corresponding to Tina's and Manna's fruits are written in that order, that means if we write Tm is a 2-digit number now, because T is also 1 digit and M is also 1 digit. The resulting 2-digit number is a multiple of 3. Tm is multiple of 3. And we know that M is 3 times T. So we can have option. If T is 1, then M is 3. If T is 2, then M is 6. If T is 3, then M is 9. If T is 4, M would be 12. That is not possible. That means the 3 possibilities are 13, 26, 39. But Tm is multiple of 3 and 39 is only the multiple of 3. How many fruits does Manna have? So here we can see that Tina have got 3 fruits and Manna have got 3 into 3, that is 9 fruits. In how many ways a team of 11 must be selected from 5 men and 11 women such that the team must comprise of not more than 3 men. Not more than 3 men means number of men can be 0, 1, 2 or 3. And if number of men are 0, 1, 2, 3, the number of women would be 11, 10, 9, 8, because total number of members in any case should be 11. Now, if we look at case 1, in how many ways case 1 can be selected? Taking 0 men, that is 5C0, into taking 11 women, 11C11. 5C0 is 1, 11C11 is 1, that is one way. If we add up all these 4 cases, 1, 55, 550 and 1650, we'll get 2256. If company A sells a service for rupees 100 per hour, then which of the following could be a revenue function of company A? T is the time in hours. Now what do you mean by revenue for this company? Revenue for this company is how many hours this company have worked, into price they are charging per hour, that would be their income or revenue. So if they are working for T hours and charging rupees 100 per hour, the revenue function would look like 100 T rupees. Option C. The sum of digits of a 3-digit number is 17. Stop. These kind of questions, if options are there, I'll always recommend you to just go to the option and try to eliminate. You'll get the answer in no time. Let's begin it again. Let's do it again. The sum of digits of a 3-digit number is 17. 8 plus 6 plus 3 is 17. 3, 6, 8 is 17. 9 plus 8 is 17 plus 7. This is not 17. 7, 8, 9 similarly is not 17. Out. Sum of the squares of the digit is 109. These two are same. That means no need to check for the sum of squares now. If we subtract 495 from the number, we shall get a number consisting of the same digits written in a reverse order. We need to deduct 495. 368 is less than 495. We can't deduct 495 from 368. So only option left is 863. Now let us check everything with 863. We know that answer is 863, but let's check. 863 minus 495. 13 minus 5 is 8. 15 minus 9 is 6. And 7 minus 4 is 3. 863 reverses 368. Fine. Gargi goes to the market to buy oranges. If she bargain and reduce the price per orange by rupees 2, then first price was P, now price is P minus 2. She can buy 30 oranges instead of 20. She would buy 20 oranges here with rate P, and with P minus 2 she can buy 30 oranges. With the money she has. So how much money she was having? P into 20, which is same as P minus 2 into 30. Given that the entire money is spent on the purchase of oranges, we can solve this. 20p equals 30p minus 60. That means 10p equals to 60. P equals to rupees 6. How much money does she have? Either it is 6 into 20 or 6 minus 4 into 30. So money she has is 6 into 20, that is rupees 120, isn't it? But if you want to use rule 1 of arithmetic, that is line changing rule, we can see that quantity purchased have increased from 20 to 30. That means it have increased by 10 by 20, that is half. That means price should come down by 1 by 3. Now 1 by 3 corresponds to rupees 2. That means 1 corresponds to rupees 6. Initial price was 6. Money she was holding was 6 into 20, rupees 120. An alphabetic series is given. A, B, B, C, 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 D, 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 E, 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 E. Okay, so that means first letter is given 1 time, then second is given 2 times, 3 times, 4 times, 5 times, and on. And we need to find the 120th letter. Suppose if we suppose that nth letter is the 120th letter, that means we need to find the total till n, and that should correspond to 120 somehow, isn't it? That means n into n plus 1 by 2 should correspond to 120 somehow. And then a long process to follow to find the value of n. Not necessarily n into n plus 1 can be broken up into 120 into 2. Here we can, but not necessarily. So is there any process by which we can solve these kind of question in no time? Yes. This concept is known as concept of triangular numbers. Whenever you have numbers like this, 1 plus 2 plus 3 plus 4 and moving till n, where you need to find the sum of first and natural number, use the concept of triangular number. Now how to use it? Sum is given as 120. Check the process please. Multiply 120 by 2. You can see that we are actually multiplying 120 by 2. That will be 240. Second step, just try to find out the root of 240. It might happen that 240 is not a perfect square of any number. So you find a number whose square is just close to 240. That is 225. 225 is 15 is square. So I'll take value 15. Now put n equals to 15 in the formula to find the summation. This is 15 into 16 by 2. That gives me 120. Bingo. That means what? The last alphabet or the last letter of the 15th alphabet in this series would be the 120th member of the series. Now, which is the 15th alphabet? 15th alphabet in the English alphabet series is, we know that EJOTY. This is 5th, this is 10th, this is 15th. 15th alphabet is O. So 120th letter of this particular series is O. There are 120 male and 100 female in a society. Out of 25 male, out of 25% male, 25% means 1/4, that is 30, and 20% female, 100 into 20% will give me 20, are rural. That means these are rural people. 20% of male and 25% of female rural people pass the examination. So how many have cleared the examination? 20% of rural male, 30 into 20% is 30 into 20 by 100, that is 6. And 25% of female rural people, 20 into 25% is 1 by 4. 20 by 4 is 5. What percentage of rural students, total rural students we have is 50, have passed the exam. Passing examination people are 11. So the required percentage is 11 by 50 into 100. 2 times it will go. That is 22%. On the island of knights and knaves, we met 3 people A, B and C. One of whom is a knight, one is knave and one is spy. The knight always tells the truth. The knave always lies. And the spy can either lie or can tell the truth. A says C is a knave. B says A is a knight. And C says I am the spy. Here is the hint. If A is saying truth, then B is also saying truth. Because if A is saying truth, so he can be a knight. If I assume that A is knight, then A is saying the truth, then C is a knave. And the knave says lies. That means C is saying that I am the spy. That is a lie. That means C is knave. And that means B is a spy. And a spy may either lie or may say the truth. Now B says that A is a knight. And yes, that is our assumption, A is the knight. That means he is not lying, he is saying truth. So we started with an assumption set of A being truth. And we end up with, yes, A knight, C is knave, and B is spy, and that fits in. So who is the knight? A. Who is the knave? C. And who is the spy? B. ACB fits in. Using principle of moments, one can weigh any item using a single weighing stone. In such experiment, a food packet was kept hanging at a distance of 15 centimeter to the left of the rod's center. It was countered by a 50-gram weighing stone kept at a distance of 45 centimeter to the right of the center. So this is 45 centimeter. And if this is in balance, then according to the principle of moments, the distance into the weight into the sine of the angle, which we known as is torque, which is not required in this case, because in aptitude type question that much of physics is not required. So we can simply calculate this as weight of food into 15 centimeter equals weight of this stone into 45 centimeter, the distance from the fulcrum. So weight of the food would be 50 into 3, that is 150 grams. How many pairs of mn of integers satisfy the equation 4m equals n square plus 15? Let us try to solve this. 4 to the power m can be written as 2 to the power 2m minus n square is 15. Okay, now we know a square minus b square is a plus b into a minus b. So this should be 2 to the power m plus n into 2 to the power m minus n is 15. Now how we can write 15 as product of two numbers? It can be written as 15 into 1, or it can also be written as 5 into 3. So let's take up this one by one. 2 to the power m plus n is 15 and 2 to the power m minus n is 1. Then if we add 2 into 2 to the power m equals to 16, that is 8, which gives me 2 cube. Therefore m is equals to 3. First value of m is 3. If I put 3 here, 4 cube minus 15 is 49, n square is 49, that means n can be plus 7 minus 7. Done. Next, if I take 5 into 3, 2 to the power m plus n is 5, 2 to the power m minus n is 3, 2 into 2 to the power m is 8, that gives 2 square. So we'll get m equals to 2. If I put m equals to 2, 4 square is 16, 16 minus 15 is 1, n square is 1, that means n is plus 1 or minus 1. So we have 4 set of solution. Of all the non-empty subsets of S is a set 1, 2, 3, 4, 5, 6, 7. We need to make subsets. How many do not contain the number S, where S denotes the number of element in S? This denotes the cardinal count. For example, 3, 4 is one such subset since it does not contain the number 2. How many elements are there in this set? 2. It should not contain 2. Now, simple. What do you mean by subsets? Subsets are the sets which can be drawn from the element of these set, taken one at a time, two at a time. Since we are dealing with non-empty subsets, we can take 1 at a time, 2 at a time, 3 at a time, 4 at a time, 5 at a time, 6 at a time, or 7 at a time. Now, when we are taking 1 at a time, there should be only one member in the subset, isn't it? That means 1 should not be there in that particular set. So except 1, let us leave 1, and now we have 2, 3, 4, 5, 6, 7. That means how many elements do we have? 1, 2, 3, 4, 5, 6. In how many ways one element can be selected out of this 6 elements? In 6C1 ways. That is 6 ways. Then we will have a subset which have got element 2. We will have a subset which have got element 3. We will have a subset which have got element 4. But it will never have element 1. Fine. Now, when we are selecting 2 at a time for subsets, let us avoid 2. So that means out of 1, 3, 4, 5, 6, 7, that is again 6 elements, I need to select 2 at a time. So whatever the set we will have, in selecting 2 at a time, suppose we have 1 3, it does not contain 2. It has, suppose we have 6 7, it doesn't contain 2 because cardinal count is 2. So if you understand this, similarly when we are selecting 3 at a time, we will avoid 3, and then out of 1 2 3 4 5 6 6 element, we need to choose 3 at a time. When we are choosing 4 at a time, we will avoid 4. Again, in how many ways we can choose it? 64 ways. When we are choosing 5 at a time, we will avoid 5, and that can be chosen in 65 ways. When we are choosing 6 at a time, we will avoid 6, and that we can do in 66 ways. We cannot have a set of 7 elements, because 7 will also appear in that particular set, and that won't be counted as far the condition is given. So how many do not contain the number, the cardinal count is 6C1 plus 6C2 till 6C6, that is equals to 2 to the power 6 minus 1. We know that NC0 plus NC1 till NCN equals 2 to the power n, but we don't have NC0 with us, so if we avoid this NC0, the total from here to here would be 2 to the power n minus 1. So our final answer is 2 to the power 6, that is 64 minus 1. 63 subsets are there following the given condition. Option A. Mary Parker, in her annual internet report, said that people of planet Brahmi are spending even more time with digital media with 6.3 hours a day in 2019, up by 5% from the year before. How much time did people of the planet Brahmi spend with digital media in 2080 in a day? Let's say they were spending X hours and it went up by 5%, that means that is 1 plus 5 by 100. This is equals to the current year's usage, that is 6.3 hours. So X equals 6.3 into 100 by 100 plus 5 is 105, 5 times 20, this is 21, so 21 3 times, 3 into 2 is 6 hours. In how many ways can we give change for rupees 100 using 1 rupee and 2 rupee coins? For example, 5 can be given in 3 ways. Okay, so that means let me have X number of 1 rupee coins, that would be 1 into X, and Y number of 2 rupee coins, 2 into Y. This should be equals to 100. So I end up getting X plus 2Y equals to 100, isn't it? This is an equation of a straight line. And if we want to find the integral values of X and Y which lie on this particular straight line, we have a very simple slope concept. How to use it now? Let Y equals to 0. Then X is equals to 100. Now what we'll do, we'll keep on increasing Y by 1 because the coefficient of X is 1, and subsequently the value of X will keep on decreasing by 2. This is what we can observe. If we increase the value of Y by the coefficient of X, the value of X, integral value of X, will keep on decreasing by the coefficient of Y, and the total will remain same as 100. Let's do with 1 or 2 examples. If I increase Y value to 1, automatically this will become 2 and this will become 98. Isn't it? 100 minus 2 is 98. That means next integral value would be 96 2, next would be 94 3, and till what point we can go? We can go till 50. When we have 50, the value of X would be 0. Now, how many pairs are there? Starting from 0, we have ended with 50 with gap of 1 in it. There are 51 such integral pairs of X and Y such that x plus 2y is equals to 100. Find the number of positive integers n less than 2000 which can be expressed as n equals to 2 to the power m plus 2 to the power n, okay, will be always written in this format, where m and n are integers. And we are looking out for positive integers. That means m and n would be greater than equals to 0, because we are looking out for positive integers. For example, 33 is 2 to the power 0 plus 2 to the power 5. Now let's see. Again, 33 is 2 to the power 5 plus 2 to the power 0. That means we need to avoid one of these as the solution, because we need only 33 one time. Suppose I take m equals to 0. Then I have 2 to the power 0. Then what can be the values of n I can have? I can have 2 to the power 0, 2 to the power 1, 2 to the power 2, till 2 to the power 10. Why? Because 2 to the power 10 is 1024, 2 to the power 11 is 2048, which is greater than 2000 anyways. So the maximum power of 2 which we can take while adding it with some other power is 2 to the power 10, isn't it? 2 to the power 10 is 1024. So now I can have numbers with this combination. And what is this combination? I can have 2 to the power 0 plus 2 to the power 0. That is 1 plus 1, 2. 2 to the power 0 plus 2 to the power 1. 2 to the power 0 plus 2 to the power 2. Till 2 to the power 0 plus 2 to the power 10. So here I can form 10. No, 0 is also there. So 10 plus 1, that is 11 of such numbers. Now let me take m equals to 1. If I take m equals to 1, I am not starting the value of n with 0. Why? Because 2 to the power 1 plus 2 to the power 0 is already taken up in the previous case. So I'll start with 2 to the power 1 and can go up till 2 to the power 10, isn't it? 2 to the power 10 is 1024, 2 to the power 1 is 2, which will add up and give me 2 to the power 10 plus 2 to the power 1, that is 1026, which is way less than 2000. So how many combination we can have here? We can have 10 combinations here, with 2 to the power 1 plus 2 to the power 1, 2 to the power 1 plus 2 to the power 2, and on. Similarly, if I take m equals to 2, this side the value of n will start with 2 and will end up till 2 to the power 10. So we will have 9 of such values. If m is 2 to the power 3, I'll start with 2 to the power 3 till 2 to the power 10. We will have 8 of such values, and we can move on till 2 to the power 9. We will have 2 to the power 9 and 2 to the power 10 left with us, 2 values. And for 2 to the power 10, if I take 2 to the power 10 in m, this cannot be any case. Why? Because 2 to the power 10 plus 2 to the power 10 is 2048, which is greater than 2000. So number of ways any number less than 2000 can be expressed as 2 to the power m plus 2 to the power n is 2 plus 8 plus 9 plus 10 till 11. That is 2 plus 3 plus 4 till 11. That is 11 into 12 by 2 minus 1. 66 minus 1, that is 65. Option A. ABC is a right angled triangle. Right angled at B. We can see that. Area of triangle ABC is 400 square centimeter. A line EF parallel to AB is drawn meeting AC at E and line segment BC at F. This is parallel. EC is 65% of side AC. So if side AC is suppose 10 units, then EC is 6.5 units. I'm just supposing it. Find the area of the quadrilateral EFBA. EFBA. Now, if we look at triangle EFC and triangle ABC, we can see angle EFC is 90 degree and ABC is also 90 degree. Fine. AB is parallel to EF, that means these two angles are equal, and this common angle C is also common to both the triangles. That means the two triangles are similar triangles. AAA congruency, these two are similar triangle. In case of similar triangle, area ratio is equal to any side ratios square. That means simply that area of triangle EFC by area of triangle ABC equals, if I take EC as the side which is opposite 90 degree, it would be EC square by, and AC at the side opposite to this 90 degree, AC square. Then what will be the area of triangle EFC? That would be EC. EC is 6.5 square by AC. That will be 10 square into area of triangle ABC, that is 400. So this will give us 6.5 square is 42.25 into 4, that is 169 square centimeter. That is area of triangle EFC. So what is the area of quadrilateral EFBA? 400 minus 169. 400 minus 169 will give us 231 square centimeter. Option A. Raja filled up a cylindrical vessel completely with wine. Okay, this is Raja's vessel. He then poured the wine into another cylindrical vessel which is owned by Rani but has a radius 20% more than that of the vessel owned by Raja. Okay, radius is 20% more. What is the percentage reduction in the height of the wine level in the new cylindrical vessel owned by Rani? So if I take height as h, which is equals to 10 suppose, and radius is also 10. Now Rani's vessel radius is 12, that is 20% more than 10, 10 plus 2, and let the height of her vessel is h. Now the volume of wine in Raja's vessel is, volume of cylinder is pi r square h. So this is pi 10 into 10 r square and h is 10. And then Rani's vessel volume is pi 12 into 12 into h. So if we cancel this, we get what? H equals 1000 by 144. 6.945. So what is the reduction in the height? Reduction in the height is 10 minus 6.945. That will be 3.055. So what is the percentage reduction in height? Percentage reduction in height would be this divided by the original height, 10 into 100, that is 30.55%. At a party, cocktail drinks, snacks and food is served. Cocktail drinks and snacks are not taken alone. Let me draw a Venn diagram for this. Cocktail drinks, snacks and food is served. Cocktail drinks and snacks are not taken alone. That means cocktail drink and snacks, this portion should be 0. All three items are also not served together. All three item portion is 0. 30% of people have only cocktail drinks and snacks. This is only cocktail drinks and snacks. This is 0 and this total is 30%. That means this should be 30%. Common area to cocktail and snacks. 20% have only food. 20% people have taken only food. 70% have snacks. In total, 70% have snacks. If everybody have something, that means total of these particular area would be 100%. Then how many people in percentage have food? We need to find the total value for F. Okay, we know that this total is 100. That means this particular total for snacks is 70. That means these three portion remaining should be equals to 30. If this is 20, this is 0, this will be 10 because total is 100. Now if this is 10 and this entire thing is 70, 30 plus 0 plus 0, this common portion should be 40. Now we can see that total of all the portion comes down to 100%. Then how many people have food? 20 only food, 40 had food and snacks, 10 had cocktail and food, and 0 people with the all three. So 20 plus 40 plus 10 is 70. Answer is 70%. 70% of the people all together have food. Given x is a function which is 4 to the power a plus b, y function of ab is 4 to the power a minus b, z is function of ab which is log a into b base 4. So we need to find the value of this particular expression. Let's take up one by one. X 2 comma 1 should be 4 to the power 2 plus 1, that is 4 cube. Y 3 comma 2 should be 4 to the power 3 minus 2, that is 4 to the power 1. Now z of x comma y, that is 4 cube comma 4, is log base 4, 4 cube into 4, that is log of base 4, 4 to the power 4, that will be 4 into, power will go in front, log 4 base 4. We know that log a base a is 1, so that would be 4 into 1, 4. Option D. X is a natural number. Sx is sum of all digits of x. Find the value of S 101, 102, 103 till 200. That means if we are talking about S of 101, that would be 1 plus 0 plus 1, that is 2. And if I am talking about S of 102, that would be 1 plus 0 plus 2, that is 3. So if I need to add these two, it will be 2 plus 3, that is 5. Now, can I solve this in this way, that I have a number 101, I have a number 102. In unit place, the sum is 3. In 10th place, the sum is 0. And in the 100th place, the sum is 2. Now, what is 2 plus 0 plus 3? That is 5. Okay, so instead of me adding up all the digits in this x, I'll try this process and let's see what we will get for the numbers from 101 to 200. Now from 101 to 200, we have got 100 numbers, isn't it? Now visualize 110 unit. We are starting with 101, we have 102, we will be having 199, and then 200. If we look at the unit column, there are 100 numbers in this unit column, starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 10 numbers. Then again 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 10 numbers. Then again 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 10 numbers. Such 10, 10, 10, 10 blocks. How many times they would be coming in the unit digit? 10 times. Then means what is the summation of unit digit number? Summation from 1 till 9 is 9 into 10 by 2, that is 45. And how many such blocks are there in the unit digit column? 10 of such blocks are there. So 45 into 10, that would be 450. So sum of digits in the unit column would be 450. Now let's check the 10th column. In 10th column, we are starting with 0, 0, 0, 0, 0, 0 till what? Till 109. Okay, from 110, we will have 111, 11, 1111 till 119. That means 10 times again. 10 times 1, 10 times 2, 10 times 3, 10 times 4, 10 times 5, and again we will have 10 times 9. So from 1 to 9, 10 times, 90 gone, 9 zeros are here and 1 zero is here. So that makes us 200 digits in the column T. So in column T, the total of the digits would be again 1 coming 10 times, 2 coming 10 times, 3 coming 10 times. So that would be 10 into 1 plus 2 plus 3 plus 4 plus till 9. That is again 45, which gives us 450. Now summation of the hundreds column. In hundreds column, we have got 1, 1, 1, 1, 1. How many times? 99 times. 1 into 99 plus we have got a 2. 99 plus 2 is 101. 450 plus 450, 900, and 100 is 1001. Total would be 1001. Find the value of S101 till S200. Answer is 1001. Thank you everyone for participating. This is Mohit Jain signing off from MJ's Maths and Stats. Subscribe to the channel and stay connected. I'll see you soon. Thank you.